In this short video, we will go through the derivation of the low point, f. The learning objective for this video is simply to understand the derivation behind the f equation, which is equation 4.1.4 from the EIA Bridge Binder Volume 2 design. All right. During this process, once again, let us assume that for our span range, the cable follows a parabolic shape, which the previous video should have also shown you that under a uniform dead load or a uniform load, the cable will deflect in a parabolic shape. And we'll also note that the f point does not occur at L/2 at midspan. So this is a common misconception. This would only be the case if the towers had zero height difference between them. Once there is a difference in height, that delta H, the low point is always going to skew towards the lower side. So in the diagram here, we have a typical bridge profile. Delta H is the vertical distance between the two towers. H sub x is the sag value, or the vertical distance from the cord drawn between the two towers to the cable at midspan. And x represents the fact that we have different sag conditions: construction, hoisting, dead load, or live load, or total load. And I'll urge you to reference the EIA Bridge Binder Volume 2 design for more information on these conditions and when they occur. F low is our distance from the low tower to the low point on the cable, and this is what we're interested in deriving. So first, we'll take the equation of a parabola, and we can define 3 points. So we have our equation of the parabola here, and we'll define 3 points. Point 1 will be 0, 0 on the left-hand side, and this helps us define C as 0. So at 0, 0, we have C equals 0. Point 2 will be the right-hand side abutment defined by x equals L and y equals delta H, which allows us to arrive at this equation when we plug it into the parabolic equation with C equals 0. And then point 3 will be at the midpoint, where x equals L/2 and y equals delta H/2 minus sag. And that helps us arrive here when we plug that into the parabolic equation. Now, in order to better simplify our equations and introduce f, we will introduce a fourth equation and define the vertex, or the low point, where y equals f and dy dx, the slope of the parabola, is equal to 0. So now we can solve for a and b in terms of f at the low point. Sorry, we'll solve for x in terms of a and b. We'll plug that back in at the low point, and at point number 4, we get this equation defining a parabola. Now, finally, we can solve for a and b in terms of delta H, L, and H sub x. Then we'll plug this into the equations from above and simplify with algebra to get f. So we have an equal amount of equations, an equal amount of knowns and unknowns, and we can solve for f. So this is not an algebra course, so I'll spare you the details of writing out these long equations and manipulating everything. But I'll let you know that my strategy here was to plug the unsimplified equation into MATLAB, or whatever your favorite solver is, whether that's Wolfram Alpha or Python. And I used that to confirm that I had reached the correct value. I plugged a few numbers in, and then I used the value from the bridge binder to corroborate that. I knew I had everything sorted, and then I went ahead and did my final long simplification of the algebra, and you arrive at your f-low equation of 4h sub x minus delta h squared over 16h sub x.